here, SC17, Northeastern University. This is the second time we're doing this interview because I screwed up the first one. So now with that out of the way, introduce yourselves. What do you guys do?
I'm Carter. I'm a fourth-year computer engineering student at Northeastern, and I'm in charge of the Born application.
Okay.
I'm Jason Booth. I'm a third-year computer engineering and computer science student, and I've been working on Mr. Bays.
My name is Tristan Sweeney. I'm a fourth-year BSMS student in computer engineering, and I'm the system administrator for our cluster.
I'm Maddie Legere. I'm a fourth-year computer engineering student, and I worked on HPL and the Mystery app.
Okay.
I'm Spencer Hance. I'm a fourth-year computer engineering student, and I worked on HPCG and the Mystery app.
Okay.
I'm Zach. I'm a fourth-year computer engineering and computer science student. I'm in charge of Hyperperformance Limpack and the Tiersoft Reproducibility Challenge.
Now, I hear you guys made a hardware change. What was up with that?
Yeah, so right before the benchmarking runs, we had a discussion with our hardware sponsor, AMD, over whether or not we should keep the Radeon MI25 Instinct graphics cards that we had, which are compute graphics cards targeted at the machine learning market. So they have amazing single precision performance, but unfortunately the benchmarks require double precision.
And you considered running it twice?
Yes, we did.
That wasn't a player? That wasn't
no, Stephen Harrell was not having it. He didn't say it was okay. But so we talked with their vendor. Yes.
Yeah.
We talked with their vendor, and they approved us replacing the graphics cards. So very last minute, we had our cluster open. All the every node was pulled out. We were swapping GPUs on the fly in a panic. Had to run out onto the floor to find some extra cabling from some chassis vendors. So we had to borrow cables from Supermicro and Microwave. Okay. But at the end of the benchmarking run, we had some good runs in, which was all we could have hoped for.
Okay. So what cards are you running now?
We were able to borrow 4 NVIDIA Tesla P100s from the MGHPCC team. Because they had run their HPCG run, which doesn't push the graphics cards to use all the power they will, because it's memory bandwidth limited rather than compute limited, so they're not doing a lot of active work. Mm-hmm. But after they ran their HPCG run, they removed all of their P100s, and we were able to snag a couple of them and put them in our machine.
Okay.
Yeah.
Okay. Now, how are you using the cloud?
So we're using the cloud for the Born application. The way it works is each data set with Born is an individual file that can be done independently of the other ones and then summed up at the end. So it lets us take advantage of the cloud because we can launch a ton of concurrent virtual machines to work on the data sets side by side, and then at the end of the competition sort of merge it together.
But you were saying not quite as robust a budget as you hoped for.
Yeah, so we had been given a budget of a couple $1,000s to play out with CycleCloud, and then they told us that our budget was actually $600 for the competition, which is a lot less than any of us had expected. So for Born, we're having to do it locally and on the cloud to make sure we get the most amount of work done.
Yeah, you said that they gave you data sets for 1,000 shots.
Yeah, so each shot running the Born code base that was given to us takes 2 to 3 hours on a fairly high-end node. So for example, we're running 15 cloud systems concurrently. So every 3 hours, we're able to pump out about 15 shots. And then we're running a couple locally as well.
Okay.
So we hope by the end of the competition to get anywhere from 80 to 100 shots in.
Okay. Well, great. Well, thank you guys so much. Thanks for bearing with my technical problem. And we'll come back and check in with you soon.
Great. Sounds good.
Great to have you here.